this video, we'll review sigma notation and relate limits to exact area. This is the 5.2 pre-class video. Alright, so we're going to start with reviewing what sigma notation is. So that capital letter sigma is telling us to sum. It's telling us some stuff. We're starting at I is equal to 1 and ending at I equal to n. And the things that we're adding is a subscript I. A sub I are the things that we're adding, and we're adding n of them. So you can see on the right hand side of the equation, we have a sub 1, a sub 2, a sub 3, all the way to a sub n, and we're adding them all up. Let's look at some examples. So let's do the summation from I is equal to 1 to 9, and the thing that we're summing up is 3. So if we do that, well, a1, a2, a3, all the way to a9 is just 3. So that means we're adding up 3 9 times, which is 27. All right, let's look at another one. The summation from I is equal to 1 to 5. So we're adding 5 terms. It says a sub I is equal to I. That means a1 is equal to 1, a2 is equal to 2. So therefore, we're adding up 1, 2, 3, 4, and 5, which is 15. Here's another example. So we're summing from I is equal to 1 to 4. And now a sub I is equal to 5i squared. That means, for example, a3 is equal to 5 times 3 squared. So here's our summation, right? I is changing from 1 to 4, adding up 4 terms. I could rewrite that by factoring out the 5. And this ends up being 150. But notice I could rewrite that sum as this. It'd be 5 times the summation of I squared from I equal 1 to 4. Right? Because I'm able to factor that 5 out. It's common to every term. So I can just multiply the whole sum by 5. That's a property of sums. Here's another example. We're summing from I equal 1 to 3, and the terms that we're adding are I plus I squared. So we're adding 3 terms, but each term has kind of 2 parts. For example, a sub 2 would be 2 plus 2 squared. That would be the second term that we're adding within those 3 terms. So there it is. That's what the summation notation means. Notice since we're adding, we can rearrange those terms and rewrite those 2 parentheses as their own separate sums. That's another property of summations, is you could split it up like this if the terms you're summing consist of a sum. The reason we introduce sigma notation is when we're calculating areas under curves, we use rectangles. We're going to add up the areas of the rectangles. We're adding up multiple terms, just 3 in this case. Well, we can use sigma notation to make it a lot more compact. And we can rewrite that again because the areas were heights times base. So we can write that in sigma notation. The summation from I equal 1 to 3, and the things we're adding up is our function evaluated at x sub I times our delta x. Now let's look at a graph when we use more and more rectangles. So again, let's look at when we have 3 rectangles. Let's look at 10 rectangles now. Alright, looks like this is a better approximation than before. How about 20 rectangles? And then 50 rectangles. Looks like we're doing better and better. Now the idea is to get an exact area under the curve from 0 to 3, so let the number of rectangles go to infinity. We have this new notation for that. For letting the limit as n goes to infinity, we'll replace that sigma with this elongated s. We have to say we're going from 0 to 3, and then f evaluated at x of I, this turns into f of x, and our delta x turns into a dx. So this is new notation, and we'll look at this more in class. But that's it for this video. Hopefully you're warmed up for class.